Here's another formula we can use. It's called for continuously compound interest, not compounded once a day or once a year or once a month, but compounded continuously. So we're going to say A equals PERT, P times e to the RT power. A is the total amount we have, T is our time in years, P is the principal, the amount we're going to invest or borrow, and R is our interest rate. So suppose you borrow or you deposit $700 into an account paying 3% annual interest compounded continuously. What's the balance after 8 years? Well, in this problem, P is going to be 700. R is going to be 0.03. In T, my time is going to be 8. So we're going to say A equals 700 times E to the 0.08 times 8. Because T is 8. So we'll use our calculator to round this. We're going to say 700 times E to the 0.08 times 8, which is $1,327.54. Okay, in example 11, how long would it take for your balance in your account to reach at least $1,200? So in other words, I want my A to be 1,200. My interest rate isn't going to change. That's going to be 0.03. I don't know my time this time. Call that T. So we're going to say, and we're going to start with 700 because our P doesn't change from the previous problem. That's the same also. So we're going to say A equals, well, in this case, A is 1,200. So 1,200 equals 700 times E to the 0.03x power. Now we're going to solve this equation. So I think what we'll do is we'll divide both sides by 700. Notice my zeros reduce and I get 12 over 7 equals e to the 0.03x. Then I'll take the natural logarithm of both sides. So the natural logarithm of 12/3 equals 0.03x times the natural logarithm of e. So to solve for that, well, the natural logarithm of e is 1. So we're going to say the natural logarithm of 12/3 equals 0.03x. So we'll divide both sides by 0.03. And we'll round it to the nearest penny. So we'll say the natural logarithm of 12/3 divided by 0.03. I don't know why I didn't say 4. 12 divided by 3 is 4. So we'll say the natural logarithm of 4 divided by 0.03. Get an extra 0 in there, don't I? So we get $46, not 46, the time would be 46.21. So 46.21, and so I would say about 47 months. Because you can't have part of a month there. Last problem, it says, how much would you have to have deposited in order to reach a balance of $1,500 after 12 years? So now this time I'm looking for P, aren't I? So A equals P to the ERT power. I want to find out what my balance of $1,500 is. I don't know how much I'm starting with, but I do know it's 0.03 times 12. Geez. I think I'll just use my calculator for that part. So 1,500. Let's take e to the 0.03 times 12. Okay, we get about 1.4333. So we have 1.4333 times P. Well, to solve for P then, we'll divide both sides by 1.4333. So we'll use our calculator here. And we're going to say 1,500 divided by 1.4333 gives me about $1,046.51. How much money you have to deposit in order to have $1,500 at the end of 12 years.